Hey guys, welcome to question FM315 of the Further Maths Fortify study guide. This question reads, two circles of radius 75 millimeters are placed directly next to each other so that they are just touching. A belt is wrapped around the circles as shown below, and then we're given a diagram that looks a bit like this. Now, of course, in your diagram, the edges of the circles will be touching. I've just missed here, but you get the idea. Then says the area of the shaded region in square centimeters can be found by using the formula. So a few important points here. First of all, we want to know what formula or how we're going to set up this question. So the easiest way to find this shaded region is going to be to find the area of the rectangle, or in this case square actually, that would make up this intersection here. So if we were to drop a rectangle below, so the corners are the central points of the circles, so just where the line connects to the single point on the circle, so right on the outsides there. So it should be touching just here, and just there, there, and there, and those are the four corners of our rectangle there. And then we're going to want to then we're going to want to subtract the two half circles that make up a full circle from that rectangle and be left with the shaded region around it. So we're going to set this up as a square. Now you might start off by writing this out as rectangle and then change it to square later when you realize that it's a square. That's fine. But for now, we're just going to write it down as square minus circle. The other important thing to remember here is that we're looking for the area of the shaded region in square centimeters. We want to give ourselves a reminder of that because the measurements that we've been given have actually been given in millimeters, and we don't want to end up using those millimeter measurements by accident and getting an answer in millimeters squared. So let's start with our square, which you may not recognize as a square just yet, but you will in a moment. Now, we know that this is a square because of the following. We know that from this corner to this corner here is going to be two radiuses long, or the diameter of this circle, which happens to be 150 millimeters, so 75 plus 75. We also know that between this wall and the other wall, well, the two sides of the rectangle, is also two radius or radii long. So we are going to also label this as 150 millimeters, which is what proves that we have a square there. Now our area formula for a square, s squared, which is just side length squared. Now for the side length, we're going to substitute in 150 over 10. And the reason we're putting it over 10 is because it's 150 millimeters. Dividing it by 10 converts it into centimeters for us. So 150 over 10 gives us 15 centimeters, but we're going to keep it in this form because this is the form that our potential answer keeps it in. So moving on to the area of the circle, which I actually will do over here. So having a look at the circle, the area of the circle, we're going to use pi r squared. Pi times, now substituting for the radius, once again we're not going to use that 75 that the radius gave us. We're actually going to use 75 over 10, converting those millimeters into centimeters once again. This is also squared. So substituting these back into our original little formula that we made, we should get 150 over 10 squared minus pi times 75 over 10 squared. Now, of course, there's different forms that this could take on. You could simplify this down to 15 squared and end up with 225 minus pi times 7.5 squared. There could be a bunch of different things that this is displayed as. A lot of these questions come down to just playing with the numbers and looking for equivalent values, but with enough of your own playing around with these kinds of numbers, you should be able to get your head around the different potential forms that VCAR might have their answers in. Cool. So this final expression here is looking very much like option D, which of course is the correct answer to our question. If you guys have any questions about this question, please drop them in the comments below. Otherwise, I'll see you in the next video.